Alright, in this lesson we are learning about inverse trigonometry ratios, and we only use them when we have an unknown angle, right? These are used only for this purpose. We have our normal trigonometry rules that we are used to. We've got our sine, our cos and our tan, and that's when we're trying to find side lengths of that right angle triangle. When we are missing our reference angle, however, we need to try something else. Now we always want to find this, and it's not quite like algebra in that we need to just rearrange and move the sign to the other side of the equal sign, because these two are linked. They are closely bonded because this rule only works with O over H if you have a reference angle. If you don't have a reference angle, we don't know where the opposite side is. We don't know where the adjacent one is. So we have to always link these two closely together. So when we need to pull them apart, something different has to happen. In order for us to leave this theta on one side of the equation to get it on its own so we can find out the angle, the missing angle, we need to remove this sine part, take it to the other side of the equal sign, and when we do that, it becomes an inverse trigonometry ratio, right? When we do that, what we'll see on our calculator above the sine button is if we press shift and sine, we will get what's known as an inverse sine. We don't call it sine -1, we call it inverse sine. So to find the angle, we would say theta equals inverse sine of O over H. Same rule, right? This stuff doesn't change. You'd still need to put the ratios or the side lengths in there to get that ratio, but instead you'd be finding the inverse sine, which will give you the missing angle. So the same thing applies for cos and tan. If we need to find the angle and we have an adjacent and a hypotenuse side, then we can say theta equals inverse cos of A over H. You will find, as it does with the normal rules, once you type shift cos to get your inverse cos, it will open those brackets ready for you to put those two side lengths in. Same thing is true for tan. Theta will equal inverse tan of O over A. So if we had side lengths on here, we could substitute them in and find what this missing angle is.